Hi guys. So this is question number 5, sorry. And we're gonna read the questions to see what is the information that's being given to us so we can work with it. So we have here a family wants to finance a home mortgage and is considering 3 options. So we have 3 options here. A 1-year adjusted mortgage arm at a low interest rate, a 3-year, so you have 3-year and 1-year, at a slightly higher rate. Oh, sorry. And a 30-year, let me see if I can move this. Sorry about that. Okay. So the first one is a 1-year rate. The second one is a 3-year, slightly higher rate. And then the third option to finance the home is a 30-year mortgage at the highest rate. Okay, so the 30-year has the highest rate. The 3-year is a little bit higher than the first, the one for 1 year. These are the 3 options to be considered. So both adjusted rate mortgage arms are sensitive to interest rate changes, and the rates may change, resulting in either higher or lower interest charges. So this is the initial charge that they're gonna have, but maybe it's gonna be changed. Because the family anticipates staying in the home for at least 5 years, they want to know the total interest costs they might incur. Okay, so I'm going to know the total, and then these represent the payoffs associated with their choice and the future change in the interest rates and can easily be calculated using a spreadsheet. The payoff table is given below. So this is very important here, and that's what we're going to use to calculate this amount, the minimum, max, and the other things. So we have the outcome here and you have the decision. So the decisions is going to show our 3 mortgage options, 1 year, the 3-year, and the 30-year. And then the rates rise, right, from 85, 76, and 67. If they're stable, that's going to be the total amount. 57, 66, and 67. And in case the rates fall, if they decline, we're going to have a 53,000, 57,000, and 67,000. So what are the probabilities of having the rates rise? 29% of chance of the rates to be risen. So 29% of this to occur. And then what is the probability for the rates to be stable? 53%. So most likely the rates are going to be stable, right? This is the most likely scenario. So this should be our result, right? But besides the 29% of them to be risen or the 18% of chance, there's also an 18% of chance to have this last scenario here happen. Okay, so in the part 1, what it's asking us to do is use the Excel formulas and functions to determine the following calculations. Type of the decision problem and what are the payoffs from the mortgage, right? Best and worst payoffs. So we're just gonna use here. So you see, like you have one row here that's for the 1-year arm. So we're just gonna use this information here. Minimum and maximum, it's very easy. We're just gonna put equals min, and then we're gonna select these amounts here. Same for max. And then we do the same thing for the 3-year, which is gonna be this row here. And then the 30-year, that is gonna be this one. Okay, so we can start working on that. Let's see. Close min, and then we select the amounts. Okay. Years. Wait, something happened. Here, let me see. Just select them, close parentheses. Okay, equals min. Okay, so now it's going to be the same one, but for max. To find the maximum amount, the same interval. Here, and close max. Okay, so we're done here with the first section. Now to calculate the other section, we have opportunity losses, right? So to calculate if the rates rise and if they're stable and the rates fall. So these that we calculated were the best and worst payoffs, and now we have opportunity losses. So in order to get the opportunity losses, you're gonna get the amount and subtract the minimum. So what is that we're not using out of the result? So in this case here, we have the first year R, so here, and the rates rise. So rates rise for the first year is going to be here. So our opportunity loss is going to be this amount minus the minimum of the rest. So equals min, oh, sorry, equals this amount here, which is the first one, minus min, and then we select everything. Okay, and we're gonna do the same thing for the other ones. Equals this one minus min of all the possibilities. So this one is equal 53 minus the min of possibilities. And the same thing is going to happen to the other columns as well. So in this case, it's going to be 76,500 minus the minimum of the other ones. Okay, so we have this section complete. So one thing that we are going to do here to facilitate our calculation is to create two other columns here, right? That's going to be very useful for us. I'm just going to write here as the minimum, and here because it's the minimum loss, I'm going to do the same thing. Okay, opportunity loss. Okay, so what I'm gonna do is equals, okay, I'm gonna do the maximums and the minimums. Max, select the amounts. Okay, perfect. And just dragging it down. But here, instead of max, I'm gonna change to min. Wait. Oh. Equals min. This amounts. equals main. That's perfect. Okay, I'm gonna do the same thing on the other side. Here's the max, minimum, max, minimum, max, and minimum. Yeah, perfect. Let me just see if I did this correctly. Okay, sounds good. Right, so we have our section complete now. So type of decision problem and what are the payoffs? So the type of decision problem that we have is to minimize the objection, right? Because the idea here is that you want to see the one that is going to be like lower interest rates. Okay. You want to know the total cost of interest that you're going to incur, and then what are the payoffs are going to be related to the total interest costs. Let's close down our part of the question, and then what decision should the company make using each of the following strategies? So you have here decision using aggressive step strategy, conservative and opportunity loss, API value, among the outcomes. Okay, so let's evaluate like each one individually. In this case here, we can first like analyze this section. So decision using aggressive strategy, conservative and opportunity loss. So if we think about it, what's our most aggressive strategy? Is it like the 30-year loan, for example? No, the 30-year loan is not our most aggressive, right? That would be our most conservative strategy, right? That's what usually we see in the market. And this would be like our most conservative. And then even though there's not like a lot of difference between the 3-year to the 1-year, the 1-year is gonna be our most aggressive strategy. One. And then finally, our opportunity loss strategy is gonna be our 3-year arm. Okay, so for the payout values, we already have them here as well. So for the 1-year arm, we can come here, we can see that it's 53, right? You just reference the amount to the 53. You could also like just type the minimum formula here as well, but because we did this to visualize, that's gonna be easier. Okay, so our most conservative strategy would be the 30. So we can just grab the 30 from here. It's gonna be 67. Our opportunity loss, we will grab it like from here, right? Because it's our opportunity loss. So it's gonna come from this other section. And it's related to the 3-year arm. So we can just reference this section here, right? And it was the minimum, so this amount. Perfect, so we concluded this section. So one thing that we can notice here as well is that this amounts here, they're between the minimum amounts, right? So if you take a look at these numbers and the numbers that we calculated between minimum and maximum, we can see that all of them are between the minimum amounts, right? We are grabbing like from the minimum, not the max, even though here would be the same thing. So minimum amount. Okay, here's the same. And then in this case here, we have the largest outcome, right? So we have the largest outcome for the 30-year and the 3-year. So this one would be the smallest outcome. the largest as well. Okay, so moving along to part number 3, compute the standard deviations of the payoffs for each decision. What does it tell you about the risk and make this decision? So that's going to be easier. We know like how to calculate the standard deviation, right? We're just going to use the formulas, and this is asking us for the 1, 3, and 30-year arm individually, and then we're just going to select from the drop down which one is at a greater risk according to our results. So once again, just like the other test that we did, we're not dealing with a large population here, and that's because of that, we can use the formula with S, like simple. So equals standard deviation formula. And then we're going to use the S, not for population. We can grab the amounts from here. So this one is a 1 arm. We can just grab them from here. Okay, I'm going to do the same thing for the other ones. 3-year arm. The last one is our 30-year arm. So which one is at greater risk? So we're just gonna get like the largest one here, which is the 17,000, right? Corresponds to the first year arm. Okay, so now we have our result. So now for part 4, what's decision which should be made using the average payoff strategy? So it's the average. If you sound like me, would also like to use the average formula. We're just gonna do the same thing that we did here and using the average formula, right? So equals average. And then select the numbers. Equals average. Select them. Equals average. Select the numbers. So using the payoff strategy, so we want not the highest but the lowest number here, right? So because of that, it's also going to be our first year arm. So now we have our final part 5, user probabilities given on the problem statement section to determine what decision should be made using the expected value strategy. So we have here expected value for 1 arm, which is a mortgage, 3-year, 30-year, and the decision using the expected value strategy. We're just gonna use the sum product formula. That's gonna be easier. Instead of multiplying this amount here with the probability and then adding them, we can just use the sum product formula. Okay, so sum product, this is for the 1-year arm, so I'm just gonna select this ones, then come and select the probabilities, close parentheses. The same thing for the second one, sum product. Did I write the correctly? No, sorry about that. Sum product. 3-year arm. Then select the next array, close parentheses. Forwarding for sum product. Array number 1 is a 30-year, comma, array number 2 is the probabilities, close parentheses. Okay, so now we have all of them, and we are just gonna select decision using expected value strategy. Okay, so for this one, we're also going to evaluate our lowest amount, which is going to be the 1-year arm, which is select the 1-year. Perfect. So now we have our question, it's complete, and we can move along to question number 6. Thank you.